In this lecture, we are now going to talk about what a stack is. And a stack is something that we have been talking about, if you remember, when we would say we would unwind the stack when referring to recursion. So we are now going to get a better insight as to what a stack actually is. So the first thing to know about a stack is there's a specific order in which we can insert and remove elements. So specific order in how we insert and remove elements. And now this order actually has its own acronym, and it is called LIFO. And LIFO is last in, first out. Meaning we can insert at the top and then take from the top. So think of this as a stack of plates. And I like to think of it as a stack of plates because when you put plates into the cabinet, if you add a plate here, well, you're not going to take this plate. You're going to take the plate that you recently just added in. So then you would take that plate. So last in, first out. So when we look at a stack, we'll say that this is our stack. We will say push 10. Well, now we have 10 here. And then if we push 20, and now we have 20 here. Push 30, now we have 30 here. But then if we call pop, now 30 is gone. And then if we push 40, now 40 is here. And if we call pop again, now 40 is gone. So this might seem very similar to something that we just did. So so our stack is here. Our top is here. We insert at the top. We remove from the top. So this might seem very familiar. We just did something like this with our linked list. Every time we pushed in a new value, when we called pop, that latest value that we pushed in was removed. And that is because, you might have guessed it, we implemented a stacked base linked list. So while we were learning linked list, we were actually implementing a stack as well. So that is why we're not going to spend too much time talking about a stack, because while we were learning linked lists, we also learned what a stack is and how to implement a stack. But a stack does have a counterpart, and its counterpart is a queue. So in the next lecture, we will go over what a queue is, and then we will implement our own queue. Now that we know what a stack is, we can start talking about a queue. And a queue is very, very similar to a stack because it is also dependent upon a specific order. So remember, a stack was LIFO, last in, first out. A queue, instead of being LIFO, a queue is going to be FIFO. And you might can guess what this is, but this is first in, first out. So if we visualize this and we put our queue here and we push 10, we have 10. Push 20, we have 20. Push 30, we have 30. Push 40, we have 40. And now if we call pop, 10 is gone. If we call pop again, 20 is gone. If we push 50, 50 is there. And if we pop one more time, now 30 is gone. So that is first in, first out. Basically, the oldest item in the queue is taken out. So when would something like this be useful? Well, I just kind of said it. When we want the oldest item taken care of. So think of this like a line. You're standing in line at a store trying to pay. Well, the longer you stand in line, you would like to hope that your position in line is getting closer and closer to actually being able to pay for your item and check out. And that is what a queue is. Once you are in that line, you will eventually be the first one that was in the line, so you will become the first one out of the line. So when we want to get the oldest item taken care of. And now that we know what a queue is, and that we also know that it's going to be very similar to a stack, but instead of being LIFO, we're going to be FIFO, we're going to go implement our own queue so that we can visualize how a queue's code differs from a stack's. So in the next lecture, we will begin implementing our own queue. Now that we have a good understanding of what a queue is, we are going to implement our own queue. For this implementation, we are going to use the linked list collection. So we need to bring that into scope using standard collections linked list. So now we have our linked list brought into scope. We can create our queue struct, which we're going to do over type T. And we are going to have our element of a linked list also of type T. So now that we have our struct created, we can implement methods on our queue, with the first one being our new method, which is going to return a queue of type T. And inside of here we have our queue struct, which is going to have our element, which is going to be a new linked list. So now that we have our queue created with our linked list that is going to store our elements, we can now start putting elements into our queue. But remember, a queue is FIFO, first in, first out. So we need to keep that in mind when we are pushing and popping values into and out of the queue. So our first function is going to be called onQueue, and what we're going to have is a mutable self with a parameter of a value of type T. And this is how we're going to push values into the queue. So with it being first in, first out, when we push a value in, we need to push it technically to the back. So since we are using the linked list from the collections, we have a function or a method in the linked list called pushBack. And pushBack is going to put it at the back of the line, if you will. For dequeue, this is going to be our pop method. Again, we're going to have a mutable self, and this time we are going to return our option with our value inside of it. So since we need to get the oldest element in the queue, we need to use the pop front method that is associated with the linked list, and this will get the value at the front of the queue, so the oldest value. Now we want to implement our peek method, and peek, since it's just going to return a reference, we can return an option that is returning a reference to the value, and we will say self.element.front, and front is a method with the linked list that allows us to get a reference returned to the value at the front of the linked list. So now we're going to implement our length method, and this is going to return a uSize. And then here we just want to get the length of our linked list, so we can return our length method. And then lastly, we want to implement isEmpty. And this is going to return a Boolean. And if our elements is empty, aka is our linked list empty, if it is, then we will return true. Otherwise, we return false. So it's a very simple way of implementing a queue using a linked list from the collections library. But now I want you to take some time to create the test cases for this, and this will be our assignment for this section. And then in our next lecture, we will go over my test cases to ensure that our queue is functioning properly. Hopefully you were able to successfully set up some test cases in order to test the methods that we implemented in the last lecture. So we are now going to go over my test cases for our methods. So the first thing that we need to do is just set up where we conduct our tests. So we will give it our config test, and we will call it mod test, and we will bring in our queue into scope. For our first test, we're going to actually be able to test two methods that we implemented. We're going to be able to test in adding in a couple of values, and then also test our isEmpty method. So let's go ahead and do that by creating a new queue, adding in some values. So we will say 1 and 2, and if we successfully added in values, then our assert equals on queue.isEmpty should return false. So if we successfully added in values, then our test should return false if we're looking to see if it is empty or not. So now we're going to test our dequeue method, and this is going to let us see if we are returning values correctly when we take them out of the queue. So we need to create our queue again. We need to add in some values. So again, we get to test our onQueue method even more. And now we can test if values are correctly taken out of the queue. So when we run queue.dequeue, we expect this to be sum 1. Our next test, we will evaluate peeking. So let's create our queue equals queue new, and here we will add in our typical values of 1 and 2. And when we do our assert equals, we will q dot peek, and we expect sum and a reference to the 1 to be returned. And then for our next test case, we will test out our length. So we will say let mute q is equal to a new q. We will add in a value, add in our next value, and we will assert equals q dot length and check that it equals to 2. So let's make sure we have tested all of our methods. So we did new, enqueue, dequeue, peek length, and is empty. So if we run this, we would expect everything to pass successfully, which is what we got. So hopefully you are able to see that implementing a queue is very similar to implementing in a stack. And the key difference between a stack and a queue is the order in which values are put in and taken out. A stack is LIFO, meaning last in, first out, and a queue is FIFO, first in, first out. So if you have any questions about my implementation or even one of your implementations, please feel free to ask them in the Q&A section.